Quadrilaterals, Section 5, Video 1. In this section, we're looking at proving parallelograms to be parallelograms. So we're looking at specifically parallelograms and then rectangles and a rhombus. And so for the first one, we say if we know we have a quadrilateral, we want to prove we have a parallelogram. So this is when we're thinking about our properties. And there's 5 ways to prove that a quadrilateral is a parallelogram, but you only need one to prove parallelogram. So we'll talk about these 5 different ways. The first way is to say that if 2 pairs of opposite sides are congruent, then we know it's a parallelogram. And I'm just going to write it a little shorter like that, so I don't have to write it out every time. So that's to say that if we know 2 pairs of opposite sides are congruent, then we can conclude that it is a parallelogram. And that would suffice. Another way to prove is we could say that if one pair opposite sides are congruent and parallel, then we have a parallelogram. So that's to say that if you have a pair of opposite sides that are the same length and you know they're parallel, that's going to tell you that those other sides are the same length, it's kind of like the first one but a little different. It's just another way to do it. Another way is if diagonals bisect each other, then we know we have a parallelogram. So that's to say, if you have your parallelogram down here, and you draw your diagonals, it's to say that this is equal to that, and this side is equal to that side. So if you're able to show that, then you're able to say that I know it's a parallelogram. The fourth way is if both pairs of opposite angles are congruent, then we have a parallelogram. So that's if we know this whole angle is equal to that whole angle, and likewise for the other pair, then we know it's a parallelogram. So if we can prove that those pairs are congruent, we can prove it to be a parallelogram. And the last way goes right along with the definition, that if both pairs of opposite sides are parallel, then we know we have a parallelogram. And that's just going along right with the definition. Say that side's parallel to that side, and this side is parallel to that side. It's kind of messy, but you know that that's just part of the definition of a parallelogram. So you can think of these almost like properties or definitions in converse. So if we can prove that a property is true or that a definition is true, then we can prove it to be a parallelogram. And once again, you only need one of these 5 different ways to prove that something is a parallelogram. Now if you think about rectangles, it's a similar kind of thing, only this time we know we have a parallelogram and we want to get more specific and prove it's a rectangle. There's 2 ways to do this. One is if one angle of our parallelogram equals a right angle. So if we have a right angle, one right angle, then we know we have a rectangle. So that's to say that we know we have a right angle, and we also know it's a parallelogram, so we know that these other 2 sides have to be parallel. That's what makes a rectangle, because we know all of these other ones have to be right as well, because we know it's a parallelogram. And the other way to do it is if diagonals are equal, then we know we have a rectangle. So that's to say that if we can prove that that diagonal is the same length as that diagonal, it has to be a rectangle. So that red line is the same length as that blue line. And once again, we only need to prove one of these. So if I know that I have an angle of my parallelogram that's right, I know it's a rectangle. Or if I know my diagonals are same length, I know it's a rectangle. You only need one of those two to prove. So once again, only need one. And lastly, we have a rhombus. This is the same kind of thing. If you know you have a parallelogram, you want to get more specific and prove you have a rhombus. There's 3 ways to do it. One way is if one pair of adjacent sides are equal, then you know you have a rhombus. So let's say if I know I have this parallelogram here and I want to prove that it's a rhombus, if I know that this side and the one right next to it are equal, then I know because opposite sides are equal for a parallelogram, I know that this has to be the same and those have to be the same, so I know it's a rhombus. Another way is if the diagonals bisect, so cut in half, the angles, then we know it's a rhombus. So if I draw some diagonals here, and I know that this is equal to the other side, it like bisects it, and this bisects that one, use a different color here, this is equal to that, and we can prove that it bisects that angle as well, we know it's a rhombus. Lastly, if the diagonals are perpendicular, then we know it's a rhombus. So we have a parallelogram, we look at those diagonals, and we're able to see that there's a right angle in here, 90 degrees, we know it's a rhombus. So if we can prove that they are perpendicular, we can prove it to be a rhombus.